Okay, everyone, let's start today's lesson. So welcome everyone to Science Prodigy session 27, topic force and motion. So in today's class, we will be talking about force and motion. To start off, you can start off with our warm-up from last class. You can either do the wildfire warm-up or the drought warm-up. I would advise you to try and take notes during the lesson, as it will be useful for you in the future. Without further ado, you can get started with the warm-up, and then we'll review and go over today's lesson. Okay, guys, let's go over today's warm-up. Okay, so if I call on you, please raise your hand. So if you know the answer for the wildfire warm-up, please raise your hand in participants. Okay, wildfire warm-up, Arian?
Okay, so for the wildfire one, for small fires, the way that they use is to use water from ground or air, like put it on the fire. And then the other way is to make a fuel break, which is like it stops the fire. And they use a tool called the Pulaski or something.
Okay, then that's...
You're muted.
Yep, you got the way. Good job, you got it exactly. So you got the one of the ways correct. They do spray water from the air onto fires, which is called a an airdrop. But the other way is not called a fuel break. You almost got it. It's called a fire break, which is used to dig like dams and ditches with a tool called a Pulaski. Good job on remembering the tool and the two ways, as it is pretty tricky for most people. So good job. Okay, next person. Or does anybody know the answer to the drought warm-up? Name 2 types of droughts and their definition. Please raise your hand in the chat, in participants. Anyone? Okay, Adam. Let's see. Do you have an answer, Adam?
So there's the agricultural one, where like it's hard for the agriculture to grow, so the farmer supply water go down. And there's the no, I had it in my mind.
That's okay. You got one of them down, agricultural drought. That is one of the droughts. And its definition is it's a drought which causes plants, especially crops, to have a significant water decline, causing them to either dry out or not be able to reproduce. Okay, does anybody know one more type of drought? Okay, Kartika? You know another type of drought? That's okay. Okay, then I'll ask Shabang. Do you know another?
The hydrological drought.
Yep, that's correct.
And I don't know the definition really.
That's okay. So hydrological droughts are used when rivers and water bodies have a low source of water. That's a hydrological drought. And it usually, and other reservoirs, but it mainly follows after a meteorological drought, which is when weather patterns are dry. Okay, then that was today's warm-up. Let's go on to today's lesson. Okay, 1 second. Okay, let's start. What is motion? Start off with motion. So I'll quickly tell you something, guys. But force and motion and our following lessons will be a little bit more tricky. So if you cannot keep up, that's completely okay. But I highly recommend you to take notes, as you can use it on the test, the quiz, and you can use it for further reference. Okay, then. So we will be going more in depth than you should go in school. Okay, let's continue. Everything in the universe moves, but it only happens to be a small amount of movement and very, very slow. But movement does happen. Don't forget that even if you appear to be standing still, the Earth is moving around the sun, and the sun is moving around our galaxy. The movement never stops. In science, motion is a change in position compared to a place or an object that is not moving. The place or object that is not moving is called the frame of reference. What is motion? For example, a car is in motion when the ground is the frame of reference. In this situation, we think of the ground as not moving, but the ground as a part of Earth is in motion when the sun is used as the frame of reference. This is because Earth travels around the sun. Types of motion. So there are many different types of motion. Translation motion, also known as linear motion. Translational motion may be described as the movement of an object in a straight line, like a vehicle traveling on a road or an object falling down due to the gravitational pull of the Earth. A type of motion in which all parts of objects move the same direction in the given time is called translation motion. So for those who don't know what linear means, so in math, which you will learn later on in your years, but in math, you might know what a coordinate plane is. This is our y-axis, and this is our x-axis. Sorry. So this is 0, 0 right here. And let's say this is 10, 10, right over here. This is 10, 10, 10, 10. Now, a linear line, which is in a pattern, but the thing about this pattern is that it goes in a straight line. So for example, it might be just adding 1 to y and adding 1 to x. So it'll just be like 1, 1, 2, 2, 2, 3. So it'll be a straight line all the way to 10, 10. And this line is linear. Now, let's say that it's a different type of line on a coordinate plane. And instead, it goes from 0, 0 to 2, 1 to, I don't know, 9, 2, 2, 9. And then it goes down to 3, 3. And then it continues straight and then goes up again and then in a random direction. This is not a linear line because it's not in a pattern, first of all, and it's not a straight line. So we can clearly see that this is a non-linear line. So we can use that in the type of motion because translation motion is the movement of an object in a straight line. That's why it's also called linear motion. Okay, so that's, if you don't know what linear is, that's why it's called linear motion as well. Okay, next, rotational motion, also known as rotary motion. Rotational motion is the movement of an object in a circular path along a fixed point as the appointed center, and the movement is along the circumference of the path at a regular distance from the center. For example, a merry-go-round, the blade of a windmill, or the blades of a rotating fan. So let's say we have our windmill over here. So we have our point here. Then we have our 3 big things. 1, 2, and 3. So this is our windmill. But now, for example, if you don't know, this windmill is going in a straight circle around the tops. It doesn't shorten. It doesn't suddenly change its path and go down and then up. It doesn't suddenly go up and then down. It doesn't, these blades don't get longer or shorter by any chance. And it doesn't curve and point and keep on pushing in one way. It goes in a circle, and that is a circle that circle is a perfect circle. So that's just the circumference of the path. So this, if you guys can see, it makes a circle. The circumference is the outer part of the circle, the length and the length of the outside part of the circle. This is the circumference. The area is the distance, is the amount in the circle. The circumference is the distance around the circle. So that's why with our appointed center in the center of the windmill, it keeps on turning, but only on this path. It will never get off this path. That's why it's a rotational motion. It goes in a circle, because if it starts here, if it goes in a circle, it will end here, and then it'll keep on going in that same direction. And lastly, we have a periodic motion. Periodic motions are a motion repeated in equal intervals of time. This is called a periodic motion. For example, a rocking chair, or the oscillation of a pendulum in a clock, the earth rotating on its axis, or the hands on a clock. So in a pendulum, if you guys don't know what a pendulum is, it's, for example, we have these, you might have seen these, we have these three kind of objects, and what will happen is that, I forgot its name, but what will happen, I think it's called a pendulum, but they were all together, and what will happen is if you do pull this one up and let go, it will put force onto this one, which will put force on this one and force on this one, but this has no force to put on, so this will just go up. And then as this goes up, it comes back down, and then it'll go the other way as well. So this is a periodic motion because it goes in a time. There's a time interval. So it takes 1 second to come down, and then 2 seconds to come here, and then 1 more second up there, and then another second. So that'll be 1, 3, 4, and then 1, 3, 4. So it'll take 4 seconds to go from left to right, and 4 seconds again from right to left. But it is a periodic motion as there's a time and it is equal. It won't become 4 seconds and suddenly this will take 6 seconds and this will take 8 seconds. It'll be periodic in an equal interval of time. Okay. Then there's reciprocating motion. Reciprocating motion is related to other forms of motion, in a particular oscillating motion. In this form of motion, an object is translated or moved linearly in a straight line in one direction, then back along the same path in the opposite direction until it returns to its starting point. Then the cycle is repeated. So for example, if we have a line here, we have our line, and we have a light box over here, and we have our pendulum. But instead of moving upwards, it moves sideways. So what will happen is that, oh, this is also our pendulum, sorry. And instead of moving up, it just moves sideways. It's moving. So if this moves and bangs on this pendulum, this will also bang on this one and move. Then it'll move back, same way. But the difference between the reciprocating motion and the other motion, the interval motion, the periodic motion, is that when this occurs, it doesn't have to have a specific time. So for example, this part of the pendulum over here could go back for 2 seconds and then come back for 2 seconds. But when it hits it and goes this way, it takes 4 seconds and comes back in 1 second. So it's not a periodic motion because the time intervals are not the exact same, but it is reciprocating. It is still going in away as it's a cycle. And lastly, we have oscillating motion. Things that move in a reciprocating manner, but with elements of rotational motion like swinging, are said oscillate or oscillating motion. A pendulum which swings from a fixed point of attachment and traces an arch is a classic example. Now, you guys might have seen this at roller coasters at amusement parks. So they'll have one of those rides where it's like a swinging kind of thing, like one of those boat kind of things, but instead of a boat, it's one of those extreme rides where it'll go one way a little bit, then it'll go higher another way, and then it'll go even higher and then higher until it goes in a whole circle. And then eventually when it comes so high like here, it'll just make a whole circle and come back. Now that's an oscillating motion because it is going in a rotational motion. It's going in a circle. But it's also going as a reciprocating motion, as it is going from one way to the other. Now, the only problem with this is that if our ride over here stops right here and doesn't have enough energy to continue going, and it just keeps on going from here and here, and it does not complete this small part to make a whole circle, it's not an oscillating motion because it's not part rotational. It's not making a full circle. It just is like a very enlarged semicircle, as it never does make a circle over here, never closes the circle. Okay, so according to directions, what are the types of motions according to direction? There is one-dimensional motion. One-dimensional motion is the motion of a particle moving along in a straight line. That's pretty obvious. That's pretty simple. Two-dimensional motion is a particle moving along a curved path in a plane. That is a two-dimensional motion. And lastly, a three-dimensional motion is a particle moving randomly in space, which is a three-dimensional motion. According to states of motion, a uniform motion, a body is said to be in a state of a uniform motion if it travels in an equal distance in an equal interval of time. If the time distance graph is a straight line, the motion is said to be a uniform motion. Non-uniform motions, a body is said to be a non-uniform motion. It travels an unequal distance in equal intervals of time. Time distance graphs of bodies in a non-uniform motion is a curved line. Okay, so let's say that, for example, we have I don't know, let's say a swing. No, let's say a car, right? Yeah, a car is fine. Sorry for the bad drawings. So let's say we have our car here. Now our car is traveling from place A to building A to building B. Now what's happening is that on this road, right, the distance from A to B is 60 miles. 60 miles, okay? 60 miles. Now that's how far it is, that's the distance. And he reaches B, place B, in 60 minutes. 60 minutes, in 1 hour. That's a uniform motion, because we can quickly cancel it out and show that our car here is going 1 minute per mile, which is extremely fast, 1 minute per mile, 1 minute per mile. So that's 60 miles per hour. So it's going in 60 miles per hour as the distance is 60 and it takes 60 minutes. It is exactly a uniform motion. Now, for example, if our car here again, if our car back here, sorry. Now, let's say this car has to travel from building B to farm C, to the farm C. The distance, let's say is, let's say it's now 100 miles. 100 miles. Now, but the car only goes at 60, it reaches there in 60 minutes. So that's a non-uniform motion because our distance does not equal to the time. And what happens is that our car here it's not you cannot make a straight because 100 miles in 1 hour. So that's 100 miles per hour. But it's not a uniform motion as it's not going as the time and the distance is not the same. And if you do graph it, it'll be different as it might be a little bit curved and not a linear line, whereas a real uniform motion will be linear. So let me quickly show you. So let's say that in our uniform car, in our car over here, this is our minutes and this is our distance. And this is our miles and minutes. Miles and minutes. So 1, 2, 3. 1, 2, 3. So let's say our car travel, oh, sorry, not minutes. Let's make this hours. Yeah, hours is better. So what happens is our car is going 1 hour. It takes 1 hour for him to go 1 mile. So if he does go like this for 3 hours, and let's say he goes 3 hours, 3 miles right over here. That means that it's going to be a straight line. 1 hour, 1 mile, 2 hours, 2 miles, and 3 hours, 3 miles. Now let's say here, let's make this a little bit more straight so you can see. Now let's say in our non-uniform motion, in our same hours and miles, again, 1, 2, and 3, 1, 2, and 3. But instead, let's make this 5 so it's easier to see. So let's say in our second one, our car takes 5 hours to go 6 miles. 5 hours to go 6 miles. Then it doesn't matter. It doesn't go like 4 hours for doesn't act like 4 hours for 5 miles. No, 5 hours for 6 miles. That's 5/6. Then you have to make another 5/6, and then another 5/6, and another 5/6, and another 5/6, and another. And it won't be a straight line unless it's completely uniform. Okay, let's continue on. Okay, let's continue on. Okay. Uniform and non-uniform motion graphs. In our uniform motion over here, it's constant. And again, constant. But in our non-uniform motion, our time is longer and longer and longer, but suddenly it continues and goes faster. Again, like that. So I hope that you guys can see that it's completely different within uniform and non-uniform motions. Completely different rather than other ones. Okay, let's move on. Laws of motion, Sir Isaac Newton. Okay. Sir Isaac Newton's 3 laws of motion describe the motion of massive bodies and how they interact with each other. While Newton's laws may seem obvious to us today, more than 3 centuries ago, they were considered revolutionary. Newton was one of the most influential scientists of all times. His ideas became the basis for modern physics. He built upon ideas put forth from the works of previous scientists, including Galileo and Aristotle, and he was able to prove some ideas that had only been theories in the past. Newton's first law of motion, inertia. The first law of motion states, a body at rest will remain at rest, and a body in motion will remain in motion, unless it is acted upon by an external force. This simply can mean only one thing. Things cannot start, stop, nor that they can change direction all by themselves. It takes some force acting on them from the outside to cause such a change. This property of massive bodies to resist changes in their state of motion is sometimes called inertia. So that's mainly Newton's law is just mainly on inertia, which is an extremely important concept in physics, which you guys will learn later in middle school. Okay, let's move on. The law of inertia. So what is it exactly? If an object is not moving, it will not move until a force acts on it. For example, clothes on the floor of your room will stay there until you pick them up. If an object is moving, it will continue to move until forces act to change its speed or direction. For example, a tennis ball flies through the air once you hit it with a racket. But if the opponent doesn't hit the ball back, the force of gravity will eventually stop the ball, as it'll keep on flying until it reaches the ground. But whether the object is moving or not, it may resist any change to its motion. Galileo's concept of resistance to a change in motion is called inertia. Inertia is the tendency to an object to resist a change in motion. So inertia is just the tendency of an object just so that it can resist change in motion. For example, so a big brick wall will definitely have a higher inertia than something like a balloon, because it can resist any a lot of changes in motion. For example, wind does not affect the wall at all, whereas a balloon can easily be moved by wind. So Newton's first law of motion is also known as the law of inertia. Some objects have more inertia than other objects. For example, you need to move empty containers and containers filled with 20 pounds of flour. Obviously, the container filled with 20 pounds of flour is harder to move than the empty one because it has more mass. The greater the mass of an object, the greater its inertia, and the greater the force is required to change its motion. The filled container is more difficult to move because it has more inertia than the empty container. Okay, Newton's first law of motion, or inertia. This means that if a rock is in motion and nothing at all is pushing it or pulling on it, it will continue in a straight line forever, or until something pushes or pulls it. We usually don't notice the effects of Newton's first law on Earth because the atmosphere and the air will eventually slow down any moving objects. So in our first example with the rock on this page, if we do throw a rock, of course, gravity will stop it. But without gravity, it'll just keep on going and going. Without air, gravity, and atmosphere and water, it'll just keep on going for infinite times until some kind of force or motion puts effect on it. In space, moving objects will obey Newton's first law because there's no air or atmosphere or gravity. Objects at rest remain in rest. Objects in motion remain in motion, unless acted upon by an external force. A lot of inertia. Since the train is so huge, it is difficult to move the train from rest. Very little inertia. Since the baby carriage is so small, it is very easy to move from rest rather than the train, of course. An object at rest will remain at rest unless acted upon by an unbalanced force. An object in motion will continue with constant speed and direction unless acted upon by an unbalanced force. Inertia. So an object will not change its motion unless acted upon by an unbalanced force. If it's at rest, it will stay at rest. If it's in motion, it will remain at the same velocity in the same direction. Objects with a greater mass have more inertia. It takes more force to change their motion. For example, our 300 kilogram rock over here has more inertia than our 30 kilogram rock. So there are a lot of pictures here just for me to explain, because this is an extremely important thing you will need to know later on when you get into middle school. And if you guys memorize the basic thing, it'll be very easy when you use it later. So I highly recommend taking a quick definition and a quick note on the definition of Newton's first law of motion. Every object persists in its state of rest or uniform motion in a straight line, unless it is compelled to change that state by forces impressed on it. Before firing a rocket, object in state of rest, airspeed 0, engine fired, thrust increases from 0. The weight decreases slightly as the fuel burns. When the thrust is greater than weight, the net force, the thrust minus weight, is positive upwards. The rocket accelerates upwards and the velocity increases. That's how Newton's first law is applied to rocket liftoff. So let's move on to today's second topic, which is force. So force, the definition is very basic. Force is just the pull or push on an object. A force can cause an object to accelerate, slow down, remain in place, or to change shape. Force in mechanics is any action that tends to maintain or alter the motion of a body or just to distort it. The concept of force is commonly explained in terms of Isaac Newton's 3 laws of motion. The units of force, the SI unit of force is newtons. That's how the SI units are the way to measure mainly anything. For example, to measure force in this case is newtons. To measure speed, it's kilometers. To measure speed, it's kilometers. To measure speed, it's meters per second. To measure distance, it's kilometers. To measure weight, it's grams, etc. So the SI unit of force, to measure force, you always use newtons. But other units of force include the dyne and pound force, but those aren't as important. So don't forget that dyne and pound force are not the SI unit of force. That's newtons. 1 Newton is the force needed to accelerate 1 gram of mass by 1 centimeter per second squared. The interaction between 2 objects. Whenever there is an interaction between 2 objects, there is a force upon each object. When the interaction ceases, the 2 objects no longer experience the force. Forces only exist as a result of an interaction. All forces, or interactions, between objects can be placed in 2 broad categories: contact forces and forces resulting from action at a distance. Contact forces are those types of forces that result when the 2 interacting objects are perceived to be physically contacting each other. Action at a distance forces are those types of forces that result even when 2 interacting objects are not in physical contact with each other, yet are able to push or exert a push or pull despite their physical separation. So here are some examples of each of the types of forces. Now, I think just by listening to what type of force it is, you can easily sort it. Frictional force, so that's friction, and friction is when something is accelerating, to slowing it down, you use friction, and that is a contact force as it is coming in contact. Tension, also coming in contact. Normal is a contact force. Air resistance force, it's resisting by air, which is also in contact. Applied force, there is contact as something is applied. And spring force, something springs up or bounces, which is also a contact force. Action at a distance forces. Now, it's pretty obvious. Gravitational force, we all know that gravity isn't a real thing that you can touch. It is there, but you cannot physically touch gravity. That's why it is at a distance. Electrical force. Force is created by electricity, but it's not physically created by electricity unless completely moved. But if an electrical force does occur, it is an action at a distance. And magnetic force is our last one. And obviously it is an action at a distance force, as it is real, but you cannot physically touch a magnetic force. You cannot cause a magnetic force with your physical body parts. So let's talk about each one. Frictional force. As an object moves across a surface, it causes friction. Friction force can be sliding or static. Friction depends upon the nature of the two interacting surfaces. For example, a book sliding on the table and a ball rolling on the floor. Tension force. A force that is transmitted through a string, rope, cable, or wire when it is pulled tightly by the object on the opposite end is a tension force. The force flows along the length of the wire or rope. For example, a cable car or climbing a mountain using a rope. Lastly, we have a normal force. This is the force exerted upon an object that is in contact with another stable object. Usually, a normal force is applied horizontally between two objects in contact. For example, a book resting on a table or a person leaning on a wall. Now, in a frictional force, of course, when you roll a ball on an infinite floor, of course, let's say that the wall is, for example, 3 billion miles away. That's a very long time. Now, you would think, like, if Newton's law was real, as it is real, you would think that the ball would just keep on rolling until it reaches the wall. As we can, there's nothing actually blocking with which we can see with our visual eye. But there's frictional force. Friction, as I told you before, as anything rolls or moves, there's friction. Something is stopping it. It's pushing it a little bit, very slowly and slightly. Not that anyone can notice, but eventually it does cause it to stop. Now, for example, on your bike, if you have a friction gear, what it means is that if you keep it at a low, what will happen is the gears will make sure that there's not as much friction pushing. So it'll be easier for you to glide through. And whereas if you put a friction to a very high, that's used for workouts, extensive workouts, that can be helped and cause the bikes to cause you to go and bike more strenuously, as it does cause the bike to slow down. In a tension force, it's transmitted through a string, rope, or cable or wire. Of course, rock climbing using mountain climbing using a rope is tension force, because you will try pulling on the string and the rope, and that does cause force. Normal force, just leaning on a wall or just sitting on a chair and pushing on the back using the back of the chair using your back, is normal force. Air resistance force. This frictional force applies on objects when they are in the air. Often, the air resistance force opposes the movement of the object. It is noticeable for objects that travel at high speeds up in the air. For example, an airplane or a parachute. Applied force, a force with which an object has been pushed or pulled. Here, a force is applied to an object by a person or any other object. Example, a person pushing a chair to the other side of the room. And lastly, we have a spring force. It is the force which results when a spring is stretched or compressed. A spring is a metal elastic device that returns to its original form when pushed or pulled. If the spring is stretched, spring force is attractive. If it is compressed, spring force is repulsive. For example, a trampoline or a diving board, as it just springs up. Action at a distance, gravitational force. This is the force by when the Earth or Moon or other massively huge objects attract other objects towards them. All objects on Earth experience the gravitational force, which is directed downwards towards the center of Earth. The force of gravity is always equal to the weight of an object. Electrical force. It is one of the fundamental forces of the universe. It is a force that exists between all charged particles. It is all around us. It is responsible for making our hands stand on a cold day. When the hair on our head stands and refuses to be brushed, that is static energy, electricity. This is the force which allows you to see when you turn on a lamp in a dark room. And lastly, we have a magnetic force. This is a push or pull exerted by a magnet. The force of attraction between an object and a magnet is called magnetism. All magnets have north and south poles. This force is the attraction or repulsion that arises between electrically charged particles due to their motion. Examples include iron nails when placed near a magnet. So pulling force, if they're pulled on both sides with an equal force, then of course the tug of war, not the middle part, won't move. Types of forces, of course, friction force, gravity, magnetic force, applied force, buoyant force, tension force, drag force, spring force. Balance force, this is extremely important, which you will need to know in the future. That's why I'm teaching you earlier, as it will help you. When two forces which are the same size are acting in opposite directions, we call them balanced forces. And we say that the object is in equilibrium. When two balanced forces are acting upon each other, the object will not change motion. For example, in a tug of war, when if only two people are playing, one person on each side, and they pull with the exact same force, then of course it will be endless and nobody will win. It'll just end as a tie, unless someone either slows down or someone has a higher force than the other person. For example, if the object is still, it will stay still. If the object is moving, it'll continue moving in the same direction at the same speed. What is equilibrium? When equal forces push or pull an object from opposite sides, that object is in equilibrium. And the object in equilibrium is balanced. It will not move unless an extra force acts upon it. Unbalanced forces. When two forces which are not equal in size are acted upon each other, they are unbalanced forces. Unbalanced forces change the way something is moving. They can make objects start to move, speed up, slow down, or change direction. Examples of unbalanced forces. In a tug of war, your team pulls one way, the other team pulls the other way. But if one team's force exceeds or is more than the other team's force, the team with the highest force can pull the other team toward them and win the game. Pushing a broken car off-road. The car moves when a friend helps you to push the car. This is because the force given by you and your friend is bigger than the force given by the car. So for example, in a tug of war, in our balance forces, both of them are 300 newtons, so it won't change. Now on a teeter-totter or a seesaw, if two objects or two people are pushing the same force and weigh the same, then of course nothing will happen as the same force is put, as it is a lever. The forces on the person are balanced. The floor pushes upwards on the person, the gravity pulls him downwards. Exactly the same as thrust and weight. Unbalanced forces include 50 newtons and 30 newtons, which are completely different in the tug of war. 60 newtons upway with friction and 25 newtons downway with gravity and weight, and so on. A balanced force is a force in which net force is equal to 0 and there is no motion. And an unbalanced force is which net force is greater than 0, causing motion. Interesting facts about force. An object that is accelerating in a circular motion experiences a centripetal force, which we'll talk about in a very later lesson. The four fundamental forces are gravity, electromagnetic force, the strong nuclear force, and the weak nuclear force. Torque is a type of force that measures changes in the rotational speed of an object. Torque is an important feature of automobiles, especially trucks. Drag is a force that decreases the velocity of an object. Thrust is a force that increases the velocity of an object. Study of force, motion, and energy. The general study of the relationships between motion, forces, and the energy is called mechanics. It is a large field, and its study is essential to the understandings of physics. Mechanics can be divided into sub-disciplines that are kinematics, dynamics, and statics. Motion is the action of changing location or position. The study of motion without regard to forces or energies that may be involved is called kinematics. This is the simplest branch of mechanics. The branch of mechanics that deals with both motion and forces together is called dynamics. The study of forces in the absence of changes in motion is called statics. Okay, everyone, so that was today's lesson. And now that we're finished with today's lesson, I will post the quiz link in the chat and you can take the quiz. And after that, come back because after we review our quiz, we'll have a game. Let's quickly review the quiz one more time. Our name, word, class. So as if you don't remember, the frame of reference, translational motion is in a straight line. Rotational motion is a circumference. Reciprocating motion is linearly in one direction and opposite as a cycle. Oscillating motions are created by rotational and reciprocating motions. Particle along a curved path on a plane is a two-dimensional. A body that travels in an equal distance in an equal interval of time is a uniform motion. A motion of a particle moving along a straight line is one-dimensional. Choose if the statements about the law of inertia are true or false. More mass means less inertia because it cannot withstand, that's already false. A body at rest will remain at rest unless acted upon by an external force, that's true. Inertia is the tendency of an object to follow every change, that's already false. All objects have equal inertia, false. And a body in motion will remain in motion unless acted upon by an external force, that's true. The SI unit of force is newtons. Other units of force are dyne and pine force, but not the SI unit. And action at distance forces are electrical and magnetic force as they don't specific touches and come in contact, whereas our contact force include our tension force, spring force, applied force, and air resistance force. Let's quickly make sure we have everything right. Perfecta. And let's move on to today's game. Now, this, I'm just going to quickly say that if you're not amazing at math, you might want to get a calculator. So, because it's a little bit calculating, but if you just want to enjoy the show, then you don't need to. Great, let's start. A game of tug of war. In a game of tug of war occurred in school between small classes, Mrs. White and Mr. Ray. Mrs. White has 22 kids in her class, whereas Mr. Ray only has 20 kids. The tug of war starts without the two teachers competing, of course. Mrs. White's class got really excited thinking that they're going to win, so each student pulled with 30 newtons. Mr. Ray's class tried their very best, so half of them pulled with 20 newtons, and the other half pulled with 50 newtons. Eventually, one of the classes won. Which one? So which of them won? Mrs. Ray's, or Mr. Ray, or Mrs. White? Yes, after this, I will call out who got the best scores. So let's quickly calculate, because don't quickly shout out Ray or White. Now, with our 22 kids in class, and which are pulled by 30 newtons, 22 times 30 is 660. 660 newtons pulled. Now, Mr. Ray, Mrs. White, I'm just going to do M White, MW, and MR is, so we have half of them, so 10 kids performed with 20, so that's 200. But 10 kids performed with 50, which is 500. And when we add them together, we get 700 newtons. So this was a very, very close game, but eventually Mr. Ray's class won because they had a higher force. Now, let's say that half of these didn't pull with 50 newtons, but instead just a little bit less, but with 40 newtons. Who would win? Can anyone answer me in the chat? If this was 40. If Mr. Ray, if half pulled with 20, but the other half would pull with 40. Who would win? Okay, so a lot of you said the correct answer. Mrs. White, because of course you might think, oh, 20 and 40 average out to 30, but no, because you remember Mrs. White has 22 kids, 2 more. Now last one, we'll have Mr. Ray pulled with 46 newtons. Type your answer in the chat, you will win. We have a lot of Mrs. Whites. Okay, so if Mr. Ray instead of 50 pulled with 46 newtons, which one of them won? We have a lot of mixed answers. So a couple of you did get it right. It is a tie because none of them win and it won't ever end because unless one of them slows down. Because as we remember, this is 200 newtons acted upon. And instead of 500 added, this is not 500 added. We add 200 to 46 times 10, which is 460, which is 660. So 660 newtons and 660 newtons cancel out. And because they are the exact same, it will be a tie. Exactly. Okay, everyone, that was today's class and lesson. Thank you, everyone, for joining today's class, and I will see you all tomorrow. Bye, guys. Oh, wait. Yes, you made me forget. Sorry for forgetting. Don't leave 1 second about the shout outs. Yes, the shout outs. Let me call the shout outs one quick. One time. Let's quickly shout them out. Okay, so let's see. Oh, wow. Okay, so actually we have a lot of good. Okay, so if you scored more than 16 or more, because a lot of you guys got a high score. So 16 or more, you'll get a shout out. Okay. So let's start off with our 16s. And let's start off with our 16s. Aryan got a 16. Siri Venela got a 16. And Pratya got a 16. So good job to you 3 for getting 16s, as that was in our high points of the class. Congratulations, 100%. 16, that's great. Next, we have our 17s. Renel got a 17, amazing. Adam got a 17, also very nice. And that was it for 17s. Good job to both of you for getting really good scores. Next, we have our 18s. Anyone got an 18? Kartika got an 18. Very good job, Kartika, as that was, you were the only one to get 18, and that was a pretty good score, one of our highest. Next, we have our 19s. Kartikeya got a 19. Very amazing job, Kartikeya. Who else got a 19? Okay. Sanvi also got a 19. Sanvi, very good job to you as well. And Samhita also got a 19. Good job to you 3 for getting 19s. That was one of our best score. And lastly, our 20s. Anybody get full score? Okay. So only class was the full score. So the high scores were those with 19s. So very good job, everyone who got higher than 16. If you did get a little bit lower, that's okay, because this is for practice, and maybe later in the future in our in middle school or in elementary, if you do take a quiz on this type of force in motion, but in a very big topic, and it does use some of the things that we covered, you can use it. You can use your knowledge from this into your real school tests, and you'll definitely get a higher score, and you'll definitely be much better. So surprise your teacher, be good in school, and thank you everyone for joining today's class. Bye guys.